All right. Hey, everybody. Let's do a sound check. Just chime in if you can hear me okay. Uh, Lots of interesting responses on the opening question. I think I see a lot of them that say, it's approaching, we're not there yet. And I think a lot of people, that's probably a common feeling that a lot of people have. And I think part of this, trying to wrap our hands around the question of carrying capacity in humans, is how do we know when we're there, right? And I think a lot of people maybe ask yourself that question: how would you know if we're there? And I think a lot of people will probably say, well, I think we know when we are at carrying capacity, because then we'd start seeing all kinds of bad things happen, right? People would start dying off, right? Things would start collapsing, like we see in nature, right? We know that the forest has reached the carrying capacity of deer because the deer start starving, right? And so that's how we know when we've reached that carrying capacity of humans, right? We'd start seeing humans start starving, or declines in population, or some other type of major catastrophic event. The thing I'd like you to think about is, could it be possible that you reach carrying capacity well before you start seeing the immediate, the catastrophic implications, because you are able to live off of stored resources for a period of time? In other words, you live through a false sense of abundance for a number of years while having overshot your population and living in a state above carrying capacity. But think about that. All right. So let's jump into the big picture of world population today. This picture, I think, is really a striking one. This one's called Earthrise. Maybe you guys have seen it before. And what was really spectacular about this picture, there had never been a picture, believe it or not, until the humans had gone to the moon. There had never been a full frame picture of the planet at distance like this before. And until they had come around the moon and were coming back around, because the capsule had been pointed in the opposite direction, and there's audio of them in the capsule saying, "Oh my God, look at this!" And they scrambled and got a picture of this and forwarded it back to Earth. And when they interview the Apollo astronauts, one of the most striking things that is common to interviews with almost all of the astronauts from the Apollo missions was the common theme in their from their journeys was not about the moon. It was about Earth, and it was about the fragility of Earth, and it was about their sense of environmental consciousness that was raised having left Earth and having come back. And I think that's really remarkable, that of all of the things that they could have been awestruck by in leaving the planet, it was actually the planet itself. So we're going to talk about population today in the context of, well, first off, in three different things that people wrote. Three different perspectives over time. And one of them, the first one, was this guy named Malthus, which I'm sure you guys have heard about from in other classes over the years. If you haven't, his name was Thomas Malthus, and he wrote a paper and talked about the power of population. And he said, the power of population and population growth is so superior to the power of Earth to produce substance that premature death must in some shape or another visit the human race. He wrote this in his essay, The Principle of Population, and it made quite a stir and convinced a lot of people, and became a way of thinking called Malthusianism. In other words, followers of Malthus. And the idea behind it was that, unchecked population growth will continually outstrip resources, right? That human population will grow just like, rabbits in the field, and until it crashes. And it will but more importantly, he related it to the social human condition. And he talked about how it will continually prevent the betterment of the human condition. It will continually get in our own way, because we will continually have more and more babies when we're able to. And there were various types of thinking in his arguments. He talked about this idea that's been called the Malthusian trap, which is our propensity, whenever we have a period of abundance, we start having lots of babies. We utilize abundance for population growth rather than maintaining a high standard of living, or that was his argument. And he created this idea of this catastrophe that tends to happen, that populations tend to grow until the lower class has suffered hardship and want and greater susceptibility to famine and disease. And he was speaking from what he saw in England at the time, and looking over the history of England and the plagues and the war and disease and the cycles of poverty that England had gone through over the centuries. And he drew various inferences from that, and probably rightfully so, based on the data that he had. And the general conclusion from it was that population growth would always preclude real progress for humanity. And so, this is population growth on the planet. And here is Malthus down there in the 1700s, where the red bar is. And he was talking just at the very beginning of what was going to be an exponential growth in population, if only he knew what was about to happen. But the idea of Malthusianism kind of faded in the 1800s because things started changing. We were able to harness technology and actually open up and that allowed us to be able to clear more land, open up new areas to agriculture, and increase international trade, and in general, better the human condition. So population increased, but simultaneously the human condition increased. And so Malthus's ideas that population would lead to our ultimate destruction faded, because the death rate didn't increase. We were actually able to prosper. And so it was kind of like the first societies started moving into the demographic transition, right? From where we starting to get a hold and bring down the death rate, from what we talked about earlier, stage 2 to stage 3 of the demographic transition. So Malthusianism started to fade. But fast forward all the way to the 1960s. And now, of course, let me back up just a second here. Now we're way, way, way up here. Now we're way up here, okay? And the population has been skyrocketing. We went from, less than 1 billion at the time of Malthus to the 1960s, and now we're up around 4.5 billion. So the population has multiplied by a factor of 5, and people start saying, wait a minute, there's got to be some the population is growing exponentially, and the planet can't take this. There's got to be some natural limits somewhere. And a guy named Paul Ehrlich, a professor, wrote a book called The Population Bomb. And he made some pretty startling comments. Here's a quote. He said, the battle to feed all of humanity is over. In the 1970s, he's writing in 1968. In the 1970s, hundreds of millions of people will starve to death in spite of any crash programs embarked upon now. At this late date, nothing can prevent a substantial increase in the world death rate. Paul Ehrlich is what you call a neo-Malthusian thinker. And he was looking at the data as well, just as Malthus did. And he was seeing, amazing increases in population and dwindling food security at the same time, right? It was looking very much, this is when, China's population was flying off the handle at this time. It really did look like, you looked at the numbers at that time and you wondered, where in the world are we going to get all the food to feed these people? Because our population of the planet was doubling every 12 years or so at that time. Every 12 years, the population of the planet was doubling. And Ehrlich was just looking at the data saying, I don't see it. Our food supply is not doubling every 12 years. The amount of ground available for plants is not doubling every 12 years. And he made some analysis based on that fact. And he put some dates on it too. Well, you can simply look around and look out your window and realize that didn't happen, right? Ehrlich was wrong, he got particularly in trouble because he put dates on his arguments, unlike Malthus did. So the 70s came and went, and Ehrlich had a lot of egg on his face. Now, there were some reasons Ehrlich was wrong. And the biggest had to do with a revolution in agriculture that was happening right at about the same time. And we call that the Green Revolution. And that was the boom in the use of fertilizers. And right at about that time, although there wasn't massive amounts of new land being opened up, what was happening was we were figuring out how to multiply our harvest of food from the same amounts of land by a factor of 5, 6, 7 times more than we had before by putting synthetic fertilizer onto land and by using new industrialized agricultural approaches that multiplied the productivity of a given acre of land many, many times over. And that's how we were able to do it. That's how we were, because he was right about the population. It continued to skyrocket. Just look at the graph there, right? Population continued to skyrocket, but we did end up being able to feed those people through the thing that he didn't foresee, which was this green revolution in agriculture. So the population continues to grow like crazy. Let me just show, this is the world population clock. Let me make the screen show for a second. I can do this. So you can go to the world population clock on the internet. If I can make it share. There it is. Okay. And it shows you the U.S. population and the world population at any given time, right? And there it is. There's the growth in the world population. That's a baby. Every click, every time that counter goes up, that's a new baby being born. That's the world population growing as we speak. So the world population is at 7.6 billion people. So these are two numbers that I want you guys to remember. Okay, so world population, 7.6 billion. And then the US population, 329 million. And you can see the US population is growing, but growing a lot slower. And you can see down here, here's kind of the details of how it's growing. You got a birth happening every 8 seconds. You got a death happening every 11 seconds, so that counteracts it to some point. And then you've got a migration, a net migration every 46 seconds. So that brings in a net gain every 20 seconds or so. So know those two numbers, 7.6 billion world, 329 billion US. Catherine asked about carrying capacity and catastrophic events. And that's a good question. I don't know if any of us know exactly how it's going to play out, Catherine. Maybe. As to whether that's going to be the developed countries or the undeveloped countries, I don't know. There's some arguments that the undeveloped countries may do better and that the developed ones may be the ones becoming in crisis. But exactly what may happen, there's a lot of debate about that. But hopefully we can avoid crisis. So the challenge that we have is that we live on a planet with finite resources, right? There's only so much stuff. There's only so much land. There's only so much coal. There's only so much silicon, you name it, right? And you can't grow indefinitely on that. So at some point in time, that curve has to balance, that has to flatten out, right? There's no such thing as continuous growth in a finite system. Right? At some point it has to. The question is where and when, right? So that's why we talk about this question of carrying capacity. That number exists, and the question is where is it, right? And it's not just the point at which everything collapses, right? Carrying capacity is the number at which you can live and be sustainable, right? It's carrying capacity is the number at which you can continue to live and keep doing that indefinitely. So carrying capacity and sustainability are two concepts that are intimately related, right? Carrying capacity is not just not crashing. Carrying capacity is living sustainably, kind of by definition. And so when you think about it that way, and that's what I was getting at in the opening statement, when you think about it that way, well, then I would argue that carrying capacity is something that we've probably exceeded, because carrying capacity means that to have not exceeded carrying capacity means that we aren't depleting stored resources, right? In other words, to be living sustainably means that we need to be living in a way that we're not pulling down our stored resources in a way that we couldn't continue on sustainably. But unfortunately, just look at various resources that we're consuming. Think about all the things you studied in this course and prior courses that we're consuming unsustainably, right? So that's a product of our numbers, right? The number of people we are, and our actions, right? Our consumption levels and the activities that we do, our pollution levels. So the combination of the number of us and the way we act means that our impact cumulatively is more than what the planet can handle, right? Our CO2 levels are driving the climate to a point where it's not sustainable, right? If we do nothing, right, we're going to drive the climate haywire. The oceans are going to overtake the land, and we're going to tank biodiversity, right? We haven't talked about that much in this class, but in the United States, a large portion of the food that we grow is grown out in the Midwest, and it's irrigated off of groundwater. And we're pulling that groundwater that's coming up in places like the Ogallala Aquifer in Kansas and Nebraska is not getting recharged at anywhere near the rate that we're pulling it out, which in many places mean that we're going to run out of water to irrigate our crops that feeds our people. And the timeline on that, 20 years to 25 years in large portions of the Midwest, that water is not going to be there to produce those crops. That's kind of the definition of non-sustainable, right? Which means that we've exceeded the carrying capacity for feeding our people, but we're living off of stored resources at the moment, so we don't feel the pain. This is the green revolution that I talked about that kind of came in and surprised Paul Ehrlich after he had written his book. Not only was it the ability to was the fertilizers, but it was also high yielding varieties of plants, like certain types of cereals and dwarf wheats and rices that have much higher yield. All kinds of agrochemicals, not just the fertilizers, but the pesticides and herbicides, which have their own types of problems, but boy, could they increase yields. And our ability to divert rivers, drill really deeply, and bring water to places that it was impossible to grow plants before. All of those things brought in food in massive quantities that we could have never gotten before. So you saw that red line that is just virtually gone straight up and down, an exponential growth rate, population doubling every 12 to 13 years. What we are seeing at the tip of that curve right now, since Ehrlich's time, if we look at this is a graph of population growth rate. Okay, this is not growth; it's growth rate. So, and you're seeing that the growth rate is slowly starting to decrease. In other words, the tip of that red graph we'd seen before is slowly starting to tilt a little bit more flat. Not much, but a little bit more flat. It's kind of like what's happening, what we're hope is going to happen with coronavirus cases, right? The cases are still high, the number is still high, but the rate we're hoping would decrease a little bit. Well, that's what's happening with population growth, right? So the rate of growth was super high in Ehrlich's time, 2-point-something%, and now the rate of growth is starting to decrease worldwide some. Okay, doesn't mean that we're not still increasing, but the rate of growth is starting to decrease a little bit, and that is as countries move through the demographic transition, in particular move from phase 2 to phase 3, and they start to get a handle on their populations, right? Birth control starts to come in. And these are, what you're seeing here are the time periods in which 1 billion people have been added. Right? And so in recent decades, it's starting to take just a tiny bit longer, like a year or two longer for each billion to be added. But so the most recent billions were added in about 13 years. It took about 12 years for the billion before that. So even though the global growth rate peaked about 40 years ago, it's estimated that there will be another billion added in the next 15 years, and yet another billion before mid-century. And so that's got to ask anybody, make anybody start thinking, even if you don't think, even for the people who don't think, hey, we haven't crossed carrying capacity yet. Well, we're probably going to cross it by then, right? And so the challenge is, what do we do, right? What's the future for the planet if there are simply more people than there are resources, and also what's going to happen with population in the future? Those are questions we kind of need to be asking and wrestling with. And so, what do the trends say? And even with these growth rates, that as they get down to, they start going from 3% to 2% to 1%. Even what seems like relatively low numbers, their doubling times are, still striking, right? A 3% growth rate doubles in 23 years. A 2% growth rate still doubles. It just takes 35 years, right? And even a 1% growth rate still doubles in 70 years over the lifetime of a person. Even at a 1% growth rate, the population will double. So where is the population growing the fastest? This is important, right? Because the way population growth is distributed on the planet is quite diverse, right? And it depends very much where you're located. And so take a look at these countries, right? The countries that have the highest population growth rates, South Sudan, Angola, Malawi, Burundi, Uganda, Niger, Mali, Burkina Faso, Zambia, Ethiopia, Tanzania, Benin, all of them, right? Africa's struggling with moving through the demographic transition, and in particular being caught in the demographic trap that we talked about in phase 2, where there's that they're getting the benefits of medicine to decrease the death rate, but they still have really high birth rates. So in the early 70s, not too many years after Ehrlich published his book, another book came out called The Limits to Growth that took up the issue again. And this one, computers were just becoming onto the scene. And it said, we're going to use computers and modeling and dynamic variables, and we're going to start factoring in multiple constraints and looking at agricultural systems and all kinds of things that computers are able to do, and see what happens with growth and food supply. And nothing like this had ever been done before. And this was done in an academic context, and it was highly, highly controversial, because the results of it people didn't like. Why? Because it said to the world that there are limits to growth. It said you can only go so far. And this was a real challenge to the way of thinking at the time, because we were in the middle of economies thriving and being built upon one thing, and that was growth, right? Still are, actually, right? And this was an affront to an economic system and people that were getting wealthy based on growth. And a book comes out that said a system based entirely on the need for and the requirement for growth will eventually fail because we are ultimately constrained by the finite resources of the planet. And so it talked about the need to come up with some type of stabilized scenario. And it did various types of computer scenarios. And it talked about, that could delay a collapse. But in its words, only a carefully chosen set of world policies designed to stop population growth and stabilize material consumption could avoid collapse. And boy, did that not go over well. Because that smacked of government control and infringement on human rights, especially the most fundamental of human rights, right? That to have children. But the ideas in it kind of, in many ways, are coming back to visit us today because we are faced with the issue of consumption and the issue of population and the issue of dwindling resources. And so I bring these 3 books up because these ideas kind of spring back. And I want you, as we think about population in general, I want you to think not just about numbers, because ultimately it's not really just about numbers, because our population on the planet depends dramatically on what type of consumption that person is doing, right? If this world were made up of a bunch of Americans composed to a bunch of Bangladeshis, okay, well, it would be, this world could hold a whole lot more Bangladeshis than it could Americans, let's face it, right? Because our per capita consumption is dramatically higher, right? So really, when we think about this issue, we need to be thinking about per capita consumption and the combination of those 2 issues, numbers and per capita consumption. In other words, what's the footprint? Maybe so we look at it as an average footprint across all of humanity. And one of the biggest things and one of the biggest challenges that we have to face as we kind of wrestle with this issue of how many people can the planet hold is this transition among humanity toward eating higher up the food chain, right? In other words, eating more meat. You guys know this because you studied it. You studied basic ecology, right? And you know that as you move up trophic levels, right, it takes every level you go up the trophic pyramid takes 10 times more energy, 10 times more resources. So when you go from eating a plant to eating meat, right, that's 10 times more resources to create that meat than it took to create that plant. So that means 10 times more resources that you're demanding from the planet when you eat a meat-based diet than a plant-based diet. Right? That's just pure ecological energy calculations, right? So that means that societies that have a lot of meat demand in their diet are, by definition, 10 times more demanding on ecological resources. Right? So, but when you go out and look at these developing countries and look at the trends in their diet, one of the biggest things you see is a moving trend toward eating more meat. When you ask people, what types of lifestyles do they aspire to? And very often you see people talking about aspiring toward lifestyles that are more Western. In other words, more lifestyles that are more like ours. And that very often has to do, includes more consumption of meat. So we have to factor that in when we start thinking about increased population, right? And how many people the planet can handle. Let's take a look at this for a second. So this is just an infographic on that's really blurry, and I don't know why. Come on. Oh, there it goes. Okay. If the world's population lived like, right? So highlighted in color is how much of the planet it would take to support those people. So if the world's population lived like the average person from Bangladesh, that's the amount of the world we would need to support those people. If the world's population lived like the average person from India, that's how much of the planet we'd need. From Uganda, that much. If the world's population lived like the average person from China, we'd need 1.1 Earths. If the entire world's population lived like the population of Costa Rica, we'd need 1.4. And let's just keep going. If the entire world population lived at the consumption level of the United States of America, we'd need 4.1 planets. And if the entire world population lived at the consumption level of the United Arab Emirates, we'd need 5.4. And these are based on ecological footprint calculations. In other words, the amount of arable land, of productive land needed to be able to provide food and resources to support that population. So you can see, right, the trend as people's consumption becomes more and more like ours, is pushing us more and more toward non-sustainability. So by 2050, there'll be 9 billion people on the planet. That's up from this just over 7 billion right now. And the demand for food will have increased by 70%. So somehow we got to meet that demand, right? Despite the fact that yields in agriculture are starting to flatline. In other words, we seem to have maxed out what we can get from crops through adding fertilizers and manipulation of the species and such, and growing competition for land. So some way, we're going to have to figure that out. Maybe that means the world population has to start shifting to less meat. But above all, I think the biggest takeaway from this is that how many people on Earth that we can sustain ultimately depends on our consumption lifestyle. There's a study done at Harvard. If everyone agreed to become vegetarian, leaving little or nothing for livestock, the present 1.4 billion hectares of arable land could support about 10 billion people. You guys have heard about the various geologic eras, right? You know, the Cambrian and the Permian and, you know, Jurassic Park and all that, right? Well, now because we have affected the amount of the accumulation of stuff on the planet so much, many geologists are suggesting that we have created our own geologic epoch, and are calling it the Anthropocene. So let me just play a quick video.
This is the story of how one species changed a planet. The latest chapter of our story begins in England 250 years ago. Fueled by coal, then oil, several brilliant inventions appeared. They ignited the Industrial Revolution, which spread like wildfire through Europe, North America, Japan, then elsewhere. The great railways, then cars and highways, connected people across the globe. Medical discoveries saved millions of lives. New artificial fertilizers meant we could feed more people. Population rose rapidly. But this was nothing compared with what was to come. The 1950s marked the beginning of the Great Acceleration. Globalization, marketing, tourism, and huge investments helped fuel enormous growth. People swarmed to cities, which became even more powerful engines of creativity. In a single lifetime, the well-being of millions has improved beyond measure. Health, wealth, security, longevity, never have so many had so much. Yet 1 billion are malnourished. In a single lifetime, we have grown into a phenomenal global force. We move more sediment and rock annually than all natural processes, such as erosion and rivers. We manage 3/4 of all land outside the ice sheets. Greenhouse gas levels this high have not been seen for over 1 million years. Temperatures are increasing. We have made a hole in the ozone layer. We are losing biodiversity. Many of the world's deltas are sinking due to damming, mining, and other causes. Sea level is rising. Ocean acidification is a real threat. We are altering Earth's natural cycles. We have entered the Anthropocene, a new geological epoch dominated by humanity. This relentless pressure on our planet risks unprecedented destabilization. But our creativity, energy, and industry offer hope. We have shaped our past. We are shaping our present. We can shape our future. You and I are part of this story. We are the first generation to realize this new responsibility. As the population grows to 9 billion, we must find a safe operating space for humanity, for the sake of future generations. Welcome to the Anthropocene.
And it's amazing to think that we have the power that we are now able to disrupt the earth on such a scale. I want to give you an analogy that I think is really helpful to think about world population impacts on the planet. So I don't know if anybody's ever had the opportunity to travel in a third world country to see sites like this, or even travel on a bus like this. But this is not uncommon in, say, South America or India, where you'll see these public transit things, and everybody just kind of jumps on, and you hope that you make it around the next curve. And these buses, they get piled on until nobody else can hop on. But this kind of makes for a good analogy. Because the bus and this bus trundling down the road we can kind of tie an analogy to that, and how the bus makes it or not to the earth, right? So first off, up to a point, each new rider has a linear effect, right? Maybe the bus is going to tilt a little bit more, but it keeps on going, right? But then at some point, right, adding just that one more rider on the roof of that bus will cause that bus to tip over when it goes around a curve, right? That one extra person is the one that caused it to cross the tipping point, right? But there are various factors that could influence whether that bus tipped or not, right? Could be the speed, how fast that driver was going around the turn, right? It could be the weight of the passengers, if there were heavy passengers up there on the roof, or was the light ones up on the roof. It could be the condition of the suspension, right? In other words, the suspension is the springs that how well they absorb the bumps in the road, right? And if it had good suspension, then it would handle the bumps, and if it didn't, well, then a bump could really cause the bus to tilt and not tip over more easily, right? The sharpness of the turn, right? All of these things play into whether the bus actually does tip over on a turn or not, right? So some of those factors stress the bus, and some of the factors stress its ability to be able to handle stress, okay? Like the condition of the suspension of the bus. So we can kind of make an analogy between that bus and the things that were going on with it and the Earth itself, okay? So think about this. Let's say we had we looked at the bus and the things that stressed it, like the weight of the passengers, right? And how fast the driver was going, right? Well, we could relate that with the Earth to the population, right? And the per capita consumption, the things that we were just talking about, right? The number of people on the bus is kind of like the population, right, of the Earth, and the driver's speed and is kind of like how hard the people on the bus are going at it, right? That's kind of like how much the people on the Earth are consuming, right? How hard we're pushing the Earth, right? That's the factors that stress the bus, or the factors that stress the Earth, right? Then simultaneously, you've got the things that affect the bus's ability to handle all the stresses that are thrown at it. In other words, its ability to be resilient. Right? And so we talked about we talked about the condition of the suspension, or the springs under the bus, right? And if the shock absorbers, the springs under the bus are in good shape, well, then when bumps come along, they'll handle it. And if the shock absorbers are bad, well, then those bumps get thrown right up through the frame of the bus and can knock the bus over, right? And the Earth is like that too, right? So the things in the Earth that give the Earth resiliency are things like biodiversity. There are things like the areas that are preserved that keep our native species intact, like nature preserves. There are things like when we have resources that we harvest, when we set precautionary limits to make sure we're not harvesting right up to the edge, right? In other words, we have a precautionary harvest limit that says, okay, we know that we could harvest all the way down to this level, but we're going to have a precautionary limit that keeps the population 15% above that, just for safety's sake, right? Things like that are the buffers that allow for resiliency. Okay? They're kind of like the shock absorbers, right? So for when something bad comes along, that they can add resilience. Biodiversity serves that factor too. So when an area comes and gets wiped out, then biodiversity in another area can come and repopulate it. Okay? So the bus analogy kind of helps us think about how well the Earth is prepared to be able to handle difficult circumstances. Oh, as we look forward, as we look at, what's the situation with the planet in terms of, numbers and population, part of the challenge is there's a lot of uncertainty with the planet, right? Because number one, taking this analogy further, we don't know the load limit of the bus, right? I mean, we're all kind of speculating about, are we above carrying capacity? Are we under it, right? A lot of us say, well, I think we're kind of near it, right? And your comments reflect a lot of the comments in society, right? It depends. Are you an economist or are you an ecologist, right? As to how you evaluate whether we are at carrying capacity or not, right? the load limit of the bus. People are debating that. I have my own opinions, right? We don't know how heavy each passenger is. Their consumption rate, it varies by country, and how much they're going to, and what their aspirations are, right, as to what they want to be. We don't know the sharpness of the curves ahead, right? If we knew it was just going to be a straight line bus ride, that's one thing, but we have no idea what the path for that bus is going to be, and how sharp those curves are going to be, how fast we're going to be going into those curves. Right? And we don't know the condition of the suspension. In other words, the resiliency that's built into our system. We do know that we have eaten away at our levels of resiliency, and we do that by, as we've done things like reduce the thickness of the ozone layer, as we've reduced the amount of diversity, as we've harvested up against the maximum harvest. We've brought levels of species harvest in the oceans right up to, or sometimes past, the amount that is actually sustainable, right? So there's no buffer there. What we do know, right, is that the bus is approaching a threshold, and it's tilting further and further and further and further. The Earth is a whole lot like that bus in India, right, with people piled on the roof, and it being closer and closer to tipping over, right? And that's what I think a lot of you were getting at in your opening comments, right? I feel like we're close, right? And a lot of people think, okay, we've reached carrying capacity when the bus tilts over. My argument is that bus had reached carrying capacity long before the last 20 people even got on, right? The issue was the fact that we just didn't realize it because we didn't have a good sense of what those numbers were, right? That's the problem. This is an attempt. This is in your book, and this is some of the first preliminary attempts to try and get a handle on what some of those numbers are. Make sure you take some time to look at this. This was a study of, I think, it's 9 different areas of ecological limits in society. Things like biodiversity loss, chemical pollution, climate change, and then this graph tries to demonstrate, to show where we have exceeded global limits and where we are still under global barriers. And it points out 3 areas where we've exceeded. One, the nitrogen cycle. Oh, I hate this thing that keeps popping up. The nitrogen cycle in red, where we've pulled out way too much nitrogen from the air and putting it into fertilizers, and that's why we're having so much trouble with algae blooms. Biodiversity loss is another one that's in red, and climate change in particular as areas where we've exceeded global limits. Those are kind of the warning signs that we're past sustainability in those areas, and others where we're approaching it. So let's take the last section of class here and try and wrestle with this question of where is population headed? We know that in the near term, things are still growing, right? But what about the long term? And what does that mean? Which ones of these paths, red, yellow, or green, can we expect? And what are the implications of that? A lot of what's happening with the future is really going to depend on what's happening in Africa. Okay, so take a look at this study right here. As soon as this gray box goes away, these are world population projections. Okay, and a couple different model projections, and what they're showing is different scenarios of the growth. So you're looking at 2015 down here in the lower left, projecting out to 2100. Okay. So the red line is future population growth on the planet going all the way out. You can see it pretty much goes straight on up, all the way up to 14 billion people. That's Africa being stuck in the demographic trap. Okay, stuck in phase 2 of the demographic trap, where they just can't get a handle on controlling birth rate. And so with the entire continent stuck in the demographic trap, population worldwide continues to grow and doesn't level off. Now, the bottom scenario in gray is Africa moving out of the demographic trap and moving into stage 3 of the demographic transition, starting to get a handle on population growth. And what we start to see there is global population starts to decline. So the story for future world population then really depends on what happens in Africa and how fast it happens over the next several decades between now and 2100. Those 15 countries we just talked about in sub-Saharan Africa, how fast they can move through the demographic transition, or if they can at all, really dictates what's going to happen to world population trends. In the rest of the world, what we're seeing is a lot of this. Most of the westernized countries are going through this transition that we talked about in last class, through stage 3 into stage 4 and 5, and ending up with this inverted pyramid that we're seeing now in places like Japan and Germany, and which is causing some levels of concern, right? Because this inverted pyramid means a whole lot of old people and not a lot of young people to take care of them, right? And if you have a social security system like you have in the United States that we talked about, where the people down here are the ones paying in financially to the system, and a whole lot of people up here drawing from that financial pool, well, you're starting to have a system that's going to become financially insolvent pretty quickly. And so that's problematic. And that's why countries like Japan are really nervous and starting to do all kinds of things like providing monetary incentives to try and get people to have babies. But there's a big social, you guys are probably familiar with the social dynamics and socio-cultural things that are pushing Western and developed countries not to have as many kids, right? It has to do with the work culture, especially in Japan. The work culture is very brutal. In the United States, it has to do with all kinds of things, right? It has to do with the affordability crisis and people people your age not wanting to have kids because they see them as expensive. And people just delaying kids in general, all kinds of things. So you've got one thing happening in Africa, right, with the possible move out of the demographic transition. And then you've got all these Western countries that are moving into stage 4 and 5, where population's actually going the opposite direction, right? Which raises an interesting question, right? What if population moved out? Let's say the African countries did progress out of the demographic trap in the next couple of decades, right? And started to move into stage 3 and 4 and became developed countries and got good medical care and good birth control. And they started to get their populations down to replacement rate. And all of the rest of the world was in stages 4 and 5 and started getting these type V population pyramids. In other words, and we started seeing a world where population starts to decline in a significant way. There are a number of demographers and big thinkers that are saying that may be on the horizon X number of years out, maybe 100 years out, maybe 50 years out. It kind of depends. Even some thinkers like, here's our old friend Elon Musk talking about this. So I'm going to play a quick clip just to let you hear thinking from this perspective. Okay. Let me pull this up. Give me a second while this loads. Catherine, to answer your question, Catherine's asking about why are they encouraging them to have babies? That was in the context of Japan. So in Japan, the population is not growing. Okay, so in Japan, they're encouraging them to have babies because the population is on the decline. Japan is the one that has the inverted kind of upside down triangle.
I think demographics.
Okay. So I've got this queued up here. Let me just switch over to share this from, so you can hear Elon talk about this topic for a second.
I think demographics is a real issue where people are not having kids in a lot of countries, and very often they'll say, "Oh, I'll solve it with immigration." Immigration from where? If Europe has an average, or many parts of Europe have an average of a 50 or 60, they're only at 50 or 60% of what's needed for replacement, or China for that matter, they're at half replacement rate. Where exactly are we going to find 600 million people to replace the ones that were never born? I think people are going to have to regard, to some degree, the notion of having kids as almost a social duty within reason. I mean, just if you can and you're so inclined, you should. It's like otherwise civilization will just die, literally. The birth rate is strongly correlated to it's inversely correlated to wealth, inversely correlated to education, and correlated to religion. So the more religious you are, the less educated, and the poorer you are, the more kids you will have. And this is true between countries and within countries. In the US, the highest birth rate is in Utah with the woman. Yeah. I think if you're saying what are threats to civilization, the lack of people is obviously a threat to civilization. We are going to face in the mid part of the century, and particularly the latter part of the century, a demographic implosion, the likes of which we haven't seen, including the Black Plague. The math is obvious.
Okay. Now, so that's got to make you scratch your head, right? I mean, here we are in 1 second talking about how we've got so many people and the world is growing like crazy. And now he's talking about a demographic implosion and there not being enough people, right? So what are we talking about? And could both of these things be true? Well, this is really interesting. Okay. So let's take a look at this. Here's let's just talk in really general terms. This is kind of a graph of the population, projected population, the trends of where population may go. Okay. And we are kind of somewhere in here, right? We're on this kind of rapid growth, right? Nearly exponential kind of phase. We're somewhere before the peak. We don't know exactly where we are on that spot, but we know we're in this rapid growth rate phase, right? Okay. And we know, and at least I've argued today, that spot is somewhere above carrying capacity. Okay. Different people would debate that, but I'm arguing that that's above carrying capacity. Based on various sustainability indicators. All right. Now, at some point in the future, there's going to be a peak, right? Let's just assume that for a second, assuming that the countries in Africa make their way out of the demographic transition. So when that happens, then the population is going to peak. And then since it's a peak, after that, it's going to start decreasing. Okay. And that is what Elon is getting at, and what many demographers and economists and such call the demographic winter, which is that at some point in time, as more and more societies start transitioning into stage 4 or 5 of the demographic transition, population is going to start falling, and could actually start falling substantially and rapidly, because unless you're producing at exactly the replacement rate, you're losing population. So environmentally, hey, that's a great thing, right? Because we want that population to fall down and get below carrying capacity. So hey, if you're looking to finally resolve and get us, because think about this, everything above this red line, you're consuming stored resources, right? It's environmentally destructive, and you need to get below that line in order to have a sustainable society. So from an environmental perspective, this is necessary, of getting back down to below carrying capacity. But from a societal perspective, that decline in population is economically and socially very, very painful, right? And that's why it's been called the demographic winter, right? The loss of massive numbers of people would put an enormous strain on society. The people aren't there to do the jobs that were there. And very often the society is in this upside down V shape, which means a whole lot of old people need to be tended to by a dwindling number of young people, which really messes with available resources. And the projections are for a lot of social difficulties, right? So that's why, the things that Elon was mentioning in that clip, and he goes on to talk more about it, are we need to fix this, and have a social duty to have more kids. In other words, to keep the population up here. But that's an inherent conflict, right? Because keeping it up here is keeping us way above carrying capacity, which is not sustainable. And so therein lies the problem, right? Either we reduce things and go through an economically and socially destructive time to get below carrying capacity, or we keep the number of people up here and cause our resources to dwindle and face an environmental collapse later on. That's our problem, right? There is an alternative or a possible middle ground here, and that would be to essentially raise carrying capacity. Well, how would we do that? Well, carrying capacity is determined by our footprint, right? Our ecological footprint, right? So there could be more of us, and we could have a high population and have it sustainably if our individual footprints were lower, right? So that would require all kinds of things, like having a lower CO2 footprint per person, which would mean essentially moving to a very low meat consumption or zero meat consumption population, right? The same with our impact on the nitrogen cycle, on water consumption, biodiversity, et cetera. But that would be the other way to solve this problem, right? By having high population, but doing it via a low footprint. All right, so let me summarize the takeaway points from all this. Number one, our population and consumption, when looked at together, I would argue is above carrying capacity. Now, we might not see it through collapse of systems, but I would argue that through the evidence that we see that we're consuming stored resources, we're already on that path. Number two is that population is still growing rapidly, but we're starting to see the rate of growth is starting to decrease. Number three, it's likely that population growth is going to peak. When it's going to peak, we don't know. That has the biggest factor that's going to control that is what happens in Africa. And that could happen at 10 billion people. It could happen when we get to 15 billion people. It could happen in 15 years or 50 years or 75 years. We don't know. It really depends on what happens in Africa and how quickly they move through the demographic transition. which says a lot about what the maybe what our international priorities should be in terms of international assistance and development. And then finally, after that peak, population is going to decline. And we'll get into what some people call the demographic winter. That could be 100 years from now, could be 200 years from now, but that is likely going to be what happens. But probably the bigger question that we should be wrestling with is what happens between now and the peak. That's environmentally, that's our biggest concern is can we make it between now and the peak? Because that's the period of time that we're pulling down all of these stored resources. And while population is simultaneously increasing, that's, from my perspective, what we need to be most concerned about. Can we make it through the hump in world population growth as we go from 7 billion to 10 or 15 billion? Yes, we'll eventually have to deal with the economic consequences of a demographic winter. That's probably true. But the bigger concern from my perspective is, how do we make it through the peak and be able to, will there be a planet left? Will there be resources left? Will there be society left and a climate left and biodiversity left on the other side of the peak? So I'd like you to think about that. All right. That's all for today. See you guys next time.